Please join me in welcoming Nina Schick to the stage.
Well, I was going to say good morning, but I think we've moved to the afternoon now. It's wonderful to be here with Mastercard to talk about innovation, and really innovation as a force for transformation. Because I believe that we are at the start of a new industrial age, one that is going to be powered by intelligence itself. I don't think that artificial intelligence is a technology trend. Rather, I think that it is all about building the infrastructure that's going to power the next economy. It's the foundation on which every industry and society is going to be built. So the question is not whether AI is going to change the world, it's how we direct that change. Now, it seems to me, this morning as I was having my breakfast and I saw the sun rising over the Acropolis, that there really is no better place to have this conversation and really understand why this matters so much. Because we're standing here in Athens, the birthplace of democracy, the place where a civilization, Western civilization, which was built on imagination and innovation, those ideas still endure, several millennia later. What Athens reminds us is that ultimately, innovation and ideas are about power. And in every generation of history, power has rested very firmly on the technology of that age. In the 21st century, that technology is artificial intelligence. The one who becomes the leader in AI is going to become the ruler of the world. I didn't say that. That was none other than Vladimir Putin himself. And he said it in 2017. I was taking close note at the time, but many people didn't listen, or AI wasn't such a big deal then. But now it's actually simply true. Because AI is the defining architecture, in my view, of global power. It's reshaping not only economies, but militaries and security too. So the challenge and really the opportunity for us here in the West is whether democratic societies can lead in this new age of intelligence. This isn't abstract for me. The reason I'm so interested in geopolitics and technology is because I actually started my career in geopolitics. I spent almost a decade working with global leaders. And this decade, as you know all too well in Greece, was a decade of crisis, right? Economic crisis, migration, energy, war. And every crisis revealed the same truth for me. And that was that we had reached this point where technology was evolving faster than politics knew how to keep up. So in 2017, at the same time where Putin said whoever controls AI is going to rule the world, that's when I also kind of got sick of working with policymakers and EU policymakers. And I decided to work instead with technologists because I became increasingly convinced that the nexus of power in this century has everything to do with who controls the infrastructure and technology and how quickly that's evolving. So if Athens' influence in the ancient civilization rested on trade routes and ships, in the 21st century, it's all about computational power and silicon. But how did we get here? I myself am a historian, so it's interesting to reflect on what changed in the last few decades to take us to this point. Well, for the past few decades, the reason why computing and the digital age has become the cornerstone, really, of civilization, transforming everything, is due to Moore's law. Right? This was something that was posited by Gordon Moore in 1965, where he made the observation that every 2 years or every 18 months, the number of transistors on a chip, right, on silicon, would roughly double. This led to the exponential increase in computing power. It made computers not only smaller, faster, and cheaper, but it made it the foundation of our economy and our society in less than half a century. So now, of course, we know that computers power finance, medicine, logistics, and even war. Moore's law is the engine of the digital age, and you can really see how profound that change has been, how exponential that has been. A typical chip, in 1965 had 64 transistors on it, and the most sophisticated kind of hardware you're looking at today, you're looking in excess of 200 billion transistors. Okay, so that's Moore's law. But now, something far more powerful is emerging. It's not only about the power of scaling computational power through hardware, it's actually about, can we scale intelligence? And this is where the AI scaling laws come into play. Now, AI, of course, has been around since the 1950s, but it's only in the past decade, thanks to huge advances in deep learning, that we've seen phenomenal progress in artificial intelligence. And that has so much to do with the principle of the AI scaling laws. It's pretty simple, but it's profound. If you feed these models more data, more parameters, and more computational power, they will become more capable or more intelligent. So that's why you've seen this phenomenal increase over the past decade, where you had these kind of breakthrough models. Let's say in 2012, AlexNet. It had 60 million parameters, to something like GPT-4 in 2024, which was trained in excess of 1.7 trillion parameters. And when you look at the capabilities, what could AlexNet do? Well, it could identify images of cats. Cool, but not earth-shattering. And yet, in such a short period of time, GPT-4 can basically codify every bit of human knowledge as it exists on the internet. And we know that it's already being used in real-world applications. So it's already having this transformative impact. Scaling is now doubling every 6 months. So that is at a pace that's 3 times faster than Moore's law. And we already know how Moore's law has completely transformed the world. So the result is really this technology that's evolving at exponential velocity. And I should remark that the hypothesis about AI scaling is still open for debate, right? There are some who believe that AI scaling is definitely the way we're going to get smarter and more capable AI, and that's how you get to AGI and superintelligence, and others disagree. But if you're interested in this, this experiment is playing out right now in real time. How many have heard of Elon Musk's Colossus project? Okay, so this is being built right now in Memphis, Tennessee, because Elon Musk was a little bit slow to the AI game, and he very quickly decided that he wanted to build the world's most intelligent AI. And he is doing so right now by brute force scaling this unbelievable AI kind of data center or data factory in Colossus. It's going to be the world's most powerful supercomputer. So I think it's almost certain that he's going to wire together 1 million GPUs in Memphis, Tennessee by probably the end of this year. And I should just point out what a phenomenal feat of engineering this is. I mean, it's truly incredible. They kind of started building this site last year in 2024 and were able to put together 200,000 NVIDIA GPUs in 122 days. And even Jensen Huang said nobody could do this apart from Elon so quickly, right? So he's doing this experiment in brute force scale. I mean, the cost is staggering. Like I said, I think you'll have 1 million GPUs together by the end of this year. So let's see how that subsequently translates into his AI model, Grok, if it really becomes extremely intelligent. And the cost, I mean, it's phenomenal. It's staggering, right? So just putting together that hardware, I think about 40 to 60 billion. And the site itself is so big that you can actually see it from space. So this is a glimpse of what this new industrial era looks like. It is really a race to build intelligence at scale. But it isn't only capabilities that we're trying to scale, it's access. So the cost of using AI, what we call inference, is in free fall. About 3 years ago, it would cost approximately $60 to get 1 million tokens for AI usage, but within 3 years, that cost had dropped to 6 cents. So that's a cost reduction of 99.9%. So when something this powerful, and remember, we're still in this huge competition, this geopolitical contest to build capability, I don't think we're anywhere near the high watermark in terms of what's possible. But when something this powerful, let's just say we stop and the capability is what it is now and it doesn't get any better, but it's still very powerful. And when it becomes this cheap, that means it doesn't stay confined to labs, right? It moves into every industry, every transaction, every device. So AI is beginning to diffuse into the real economy at the speed of adoption. And already now we can see, if you look at the history of technology and technology adoption, the curve on AI adoption is much steeper than any technology in the past. This is why you hear unbelievable, phenomenal, staggering statistics like that the active weekly users for one application, ChatGPT, is already at 800 million. But I'm now going to get to the crux of my thesis, and that is that when intelligence, right, these capabilities, become abundant, if it's something that we can produce at such a scale, it stops being a tool. It rather becomes a utility, something that we build on top of. And this is really the heart of my thesis. I call it industrial intelligence because the whole point of this is to build intelligence like an industrial scale utility. And what's really interesting is that it turns out, and I'm going to get into this, in order to do so, we need industry. We need a lot of industry. Now, this is interesting from a historical perspective because for most of human history, intelligence has been scarce, right? It's been locked into individual human minds. But if the current mission in terms of industrial intelligence becomes a reality, then it will become abundant, cheap, almost free, and infinitely scalable. And when that happens, the economics of everything changes. But also very profound is the fact that it's reshaping the foundation of society from the ground up, starting with the two domains that matter the most when it comes to a nation's sovereignty. It's security as well as its economy, right? So it's security and prosperity. So this is ultimately, in my view, about power and sovereignty, what the ancient Greeks used to call autonomia. I hope I haven't butchered that. This is about the ability to govern one's own destiny through technological prowess. So today, what's unfolding, and by the way, geopolitics right now is the greatest show on earth, is about who controls that infrastructure of intelligence to create intelligence as a utility to power the economy and the security of the future. And the nations that master this, right, they're not just going to be competing, but they're actually going to be the dominant nations of the 21st century. I think that only two nations have fully internalized this reality, and they are the United States and China. So it's already all the way back in 2017 when really interesting things were happening in deep learning. AlphaGo came out in 2016, that the Chinese Communist Party really started to take notice. And in 2017, they released, they made it a national priority, they made it a policy priority, the Next Generation AI Development Plan, which explicitly states, right, it is the objective of the government to become the world's preeminent AI superpower by 2030. Now, the US has been leading in private innovation over the last few years, but there was no formal kind of AI strategy. And if anything, the previous administration was taking a very safety-focused view on AI, which I don't think necessarily was conducive to the actual geopolitical race that's unfolding. That changed the day that Donald Trump took office, right? Almost as soon as he took office, this administration has made technology dominance one of its key priorities, and he signed the executive order within hours of taking office to remove barriers to American leadership in AI. But also back in 2019, remember, this isn't only about the economy, it's also about military and security, is when the Chinese Communist Party announced a second strategy, its strategy to intelligentize the People's Liberation Army. And that, like I said, is about power, and this ambition was on display just last month in Tiananmen Square when Xi Jinping presided over a vast parade, and he was flanked by Kim Jong-un and President Putin. It was actually the first time the leaders of these three countries had appeared together since the Cold War. 10,000 troops marched in formation, flanked by AI-enabled drones and precision missile systems. So this was more than a military spectacle, right? It is a declaration of technological power as a means to determine autonomy. The US has responded. So as I said, this administration has really focused, has really turned the cards in terms of making this a strategic priority. The AI Action Plan, the US AI Action Plan, was released in July. And basically, it promotes aggressive deregulation, rapid infrastructure build-out, and a full stack strategy of promoting American technology and infrastructure overseas as a means of ensuring American leadership across the world. This is why you see these traveling diplomatic missions almost, where President Trump goes to the Gulf, or more recently to London, flanked by the CEOs of the hyperscalers and Jensen Huang, to sign deals worth billions of dollars, because there's an understanding that there needs to be a return to a public-private partnership, that is the way that the US is going to secure its influence and dominance in this technology contest going forward. And the interesting thing, again, looking at it from a historical perspective, is that private-public partnership model, which the Trump administration is really starting to embody, it's not without precedent. That's how the US leadership was secured in the 20th century for both the Apollo mission, the mission to send the first person to the moon, but also for the Manhattan Project, right, to develop the atomic bomb, which ended the Second World War. So that kind of spirit of partnership is what has been fundamental to leadership, and that's making a comeback. But let's talk now in a little bit more detail about what it actually means to be an AI superpower, right? What does it take? What does it actually mean? And the most important thing, perhaps, that I want to talk about is that achieving AI superpower status isn't just about writing clever software or building the latest models in Silicon Valley. You cannot innovate at the top alone. If you want to have this huge influence, you need control over what I call the entire stack, and I'm going to go through it. The first and most fundamental layer of this is an industrial and resource base, right? You need to have the foundation. You need to have access to cheap and abundant energy. You need to have access to critical raw materials. You need to be able to make things. You need to actually be able to do advanced manufacturing, and robust physical infrastructure is required, like the energy grid, like data centers. Then only you get to the second stage, which is supported by the foundation. You can think of this as like the engine of intelligence. This is AI hardware and compute. This is where you need this advanced AI chip design. You know, hands down, the US dominates on this right now. It's the reason why NVIDIA is a $4 trillion company. You need to have semiconductor manufacturing and also cloud infrastructure, right? Then only after you have the foundation and the engine of compute in place, can you actually get to the intelligence layer. This is where you talk about the models and the applications. And it's when you have all of this, right? If you really want to get to the apex, become an AI superpower, you need to have transformative AI integration, right? You actually need to apply it within every sector of your economy and your military to have this strategic autonomy. And at every layer of this stack, it is supported by talent, capital, phenomenal amounts of capital, and the right regulatory environment. You can see now, just looking at this, where the US leads. It kind of leads on the engine. Debatable about who leads on apps and models. China is catching up quickly. But the foundation, the industrial foundation, there's only one place in the world that has this type of foundation. That isn't the US, it's China. So we, for decades in the West, hollowed out our industrial base in the pursuit of globalization and efficiency. And what we're discovering now, when it comes to this geopolitical contest of this century, we're discovering that we need to have an industrial base. So let's talk a little bit about China. China's become the world's most advanced hub of skilled manufacturing. And we need to disabuse ourselves of the notion that, you know, Apple makes in China, designed in California, made in China, because it's cheap to manufacture there. No. As Tim Cook, the CEO of Apple, was already saying back in 2018, we manufacture in China because they have the most talented skill and the best ecosystem. So China has 3.5 million factories, compared to the US's 250,000. Skilled labor force in manufacturing, including highly skilled, so skilled labor about 200 million, highly skilled about 90 million. Compare that to the EU, it's 30 million. Compared to the US, 13 million. So no wonder in critical sectors, right? These are the industries of the future that are going to be powered by intelligence. Remember, I'm talking about intelligence as a utility. China isn't just catching up, it's leapfrogging ahead. Here are some examples. So BYD has already it's by market share, it's the largest producer of electric vehicles, right? It's not Tesla. Tesla has 7% market share globally. BYD has 22%. CATL is dominant when it comes to batteries. Global batteries, almost 40%. And DJI, which is about commercial drones, but of course this is a dual-use technology. Commercial drones are also used for military applications. Almost 90% of the commercial drone market. So as the Secretary of State, Marco Rubio, has warned, the United States cannot afford, and the West, right, the US and its allies, cannot afford a future where access to critical technology depends on the permission of a strategic rival. If we stay on the road we're on right now, in less than 10 years, virtually everything that matters to us will depend on whether or not China will allow us to have it. So the skewing of the industrial base required for the 21st century to one country has emerged not as efficiency, but a critical strategic vulnerability, which is why you see now globally, and like I said, geopolitics right now is the biggest show on earth, the pendulum is swinging back. Because the US and the allies want to rebuild their industrial base. And you saw this very, very in no uncertain terms when Trump took office and he got these big technology companies to commit to rebuild in America, to onshore critical production and manufacturing capabilities. So you have TSMC, they're actually creating semiconductors now in the US, $100 billion investment, followed by similar big numbers by Apple and NVIDIA. Both have committed $500 billion to building factories in the US. I actually moved to Texas last year from London because of this industrial build-out, which I think is so critical to the industrialization of intelligence, and it's absolutely fascinating seeing how quickly this infrastructure is being built out in places like Texas. Just to give you a sense of the scale that we're talking about here, the hyperscalers alone, right? The hyperscalers alone who are building this compute infrastructure, they've committed this year in CapEx $400 billion. Next year, that's going to probably be $500 billion. So this is, historically speaking, the biggest investment ever when it comes to any kind of infrastructure build-out. So that's how convinced they are of the importance of intelligence as a utility. Now, there are a few decisive choke points where asymmetric advantage may quickly add up. The first is energy. Okay, this is footage from OpenAI's Stargate data center. I mean, they call it a data center, but really it's an AI factory. I mean, the scale of this infrastructure is 50x an existing data center today. Who's heard of Stargate? So yes, so $500 billion committed in a deal with OpenAI, Oracle, and SoftBank to build. And they're building, right? This is in Abilene, West Texas, close to where I live. Now, I'm talking about energy. What's the energy requirement for a single Stargate? What are they building at? What capacity? 5 gigawatts, but also recently just declared that they're going to 7 gigawatts. That's more than several nuclear reactors combined, right? That's more than an entire small nation like Singapore. So we have completely got it wrong in terms of the energy required to build industrial intelligence. All of the kind of policy at the EU level, even in the US on energy, has been fundamentally wrong, and you see this very quickly starting to change. This is why in the US, you're starting to see, well, if we're going to have such vast infrastructure sites to power intelligence, we're simply not going to be able to sustain energy at this scale. So there's now a lot of investment going into building small modular reactors, small nuclear sites at the site of the infrastructure. Because even if you could get the energy there through cheap gas, like in Texas, there's a question about whether the grid can support it or not. So energy is going to be a critical unlocker. This becomes intensely geopolitical, again, when you think about who has actually developed energy capability at this scale, going back to my foundation, right, the industrial base where I talked about the importance of energy. Well, in 2025, the energy capacity of China is 3,600 gigawatts, US 1,300 gigawatts, and Europe only about 1,000 gigawatts. So you can see how this is going to be a really big strategic pinch point. If you want autonomia, if you want sovereignty, you need energy sovereignty. Just this year, China installed 278 gigawatts of solar power. Right? That's more than the US has ever installed in history. They are also building 33 nuclear reactors right now, but you're starting to see how through executive orders and the US AI action plan, they're very quickly trying to overturn the ferry or the tanker to start developing energy to support it at this scale. Now, Greece is actually a really interesting story here, because yes, Greece isn't a China or a US in terms of AI superpower status, but you are so geostrategically located, you're already becoming the new trade routes of the 21st century are energy and data trade routes, right? And Greece is already becoming this critical point for energy interconnectors, LNG terminals, that's connecting Europe to the Middle East and North Africa. So that's a really important geopolitical point for Greece. And the second is that it's also becoming a data hub because of the subsea data cables that run via your ocean. So Greece is a very interesting story or a use case for how a smaller country shows geopolitical power or influence or clout in this bigger overarching contest. So that's the first pinch point, energy. The second is semiconductors. Right, we've talked about silicon, the hardware. This is absolutely essential not only for compute, for training AI models, but literally semiconductors are the basis of everything from your car to your fridge to, yes, training AI models. And yet, the world runs on a single island. Over 90% of the world's most advanced semiconductors are produced by one company, TSMC, in Taiwan, right? So this is really dangerous. If there's a reason why in the Pentagon they war game, like what happens if China launches a full-scale invasion of Taiwan? Well, the balance of power overnight is upturned. This is why you see the US pushing for export controls, why they don't want their most advanced hardware to be exported to China. But you also see how China is making such a push for chip sovereignty. It was just a few weeks ago that the CCP announced that it did not want the Chinese hyperscalers or Chinese companies to import American hardware, American semiconductors, because they want to achieve chip sovereignty. Now, a third critical choke point is rare earth minerals. And again, you see this right now in geopolitics, right? It was the trade wars. China has been amping up the pressure by putting export controls on the rare earth minerals, which everything in modern life depend on, right? You can't build semiconductors, EVs, wind turbines, missile systems without these rare earth minerals. And the crazy thing is that China controls 70% of the rare earth mineral supply, right? This is the mining. But even more important than that, it isn't just about mining, it's about the advanced supply chain, about 90% of the processing capability. So other places like Australia, yes, they have a lot of rare earths and minerals, but they still all need to go to China to be processed. That's why you see how the US and their allies are very quickly trying to repatriate these supply chains. Just last week, Trump signed an $8.5 billion deal with Australia to develop rare earth minerals. It's the reason why the US is so interested in a mineral deal with Ukraine as part of the peace settlement between Russia and Ukraine. It's the reason, by the way, that Trump is so interested in Greenland too. Right? Because Beijing definitely holds the cards on this critical piece of the puzzle. But the final choke point, and we're coming towards the end here, is people. Right? None of this can be materialized, can take shape. Industrial intelligence doesn't exist without the talent to actually build it. That's why you see an unbelievably fierce competition right now for the world's best AI talent. You have people like Zhengzhe Zhao, who is the chief scientist at Meta Superintelligence now. He moved over, he was poached from OpenAI. He played a kind of seminal role creating ChatGPT. And you see these engineers being offered multi-million, even supposedly billion-dollar pay packages. But this competition for talent doesn't just exist at the elite level, because you need builders throughout the entire stack of making industrial intelligence a reality. The engineers, the electricians, who is actually going to build and operationalize this? So yes, we have a lot of fears about AI automating jobs, but where I am in Texas, where a lot of this infrastructure build-out is already starting, there's a desperate need for people. Where are the engineers? Where are the people that can build this? Who works in energy? So it's about people. Who can get the people? That is absolutely critical. Finally, to end, perhaps I should say that, going back to how I started, without a mission, the question is, what is that talent for? What's the mission? What are we trying to achieve here? Because for China, the mission is very clear. They want to use technology and fair dues for them, to overturn a century of humiliation, to come back to the historical position it occupied on the global stage. It's worth remembering that before the Industrial Revolution, China and India dominated about 70% of global GDP. It was only the Industrial Revolution that overturned that in favor of the West. So for the West, broadly speaking, democratic societies, our mission is less defined. So much talent is spent building kind of trivial apps like food delivery or 5 AI friends for everyone. And I would say that we need to think about rebuilding the foundations of prosperity and security. So Athens reminds us why democracy began, to give people autonomy, the ability to shape their own destiny. So as we build the architecture of intelligence, the question is whether we can preserve that same spirit, that same mission, or if we're going to be too busy navel-gazing to really understand what the strategic competition of the 21st century is. So the greatest competition, the greatest opportunity before us is to reimagine democracy, right, as a living engine of innovation powered by technology. In the end, it's not about machines, it's about people. It's about us. And I think the AI Action Plan put it best. This is an industrial revolution, an information revolution, and a renaissance all at once. This is the potential that AI presents. And the opportunity that stands before us is both inspiring and humbling. And it is up to us to seize it or lose it. Thank you very much.